Uh, may I share my screen? Okay. Okay. Is everyone able to see? Okay, so let me start by thanking everyone for being here today to assist my presentation about emotional artificial intelligence. I am Abdeslam Jacques-Joud, the CTO of Teradoxa Paris and the CEO of Jacques-Joud Labs in Morocco. It's with a great pleasure that I was asked if I can do an intervention about emotional artificial intelligence, and this is one of the subjects that are close to my heart and that I dearly. So for our agenda today, we'll start by talking about the two companies. Who are we? And then we're gonna talk about pets. Okay. I'm a big dog lover. I love dogs, and I've spent a huge part of my childhood playing fetch with dogs. So I always love to use this analogy when explaining the of artificial intelligence in general and of emotional artificial intelligence in particular. And then we will go to a very specific case. It's the case of conversational artificial intelligence and how language models changed the words with their great accuracy, as we recently saw with the hype about ChatGPT and more recently with the GPT-4. And we'll talk about empathy and its relationship with artificial intelligence, and before including with the fields that we are developing right now. So, who are we? We are two companies. The first one is Teradoxa, located here in France, established in 2018. Our field of expertise are artificial intelligence and applied to digital identities, as well as Web3. We hold patents for auto-validated blockchains and our own consensus algorithm. Globally, our customers are in big industrial customers here in France. So, for instance, Orano, the company that manages the uranium from extraction and until it reaches nuclear reactors, as well as MBDA, the company that's working on on developing and selling French missile systems. On the other side of the Mediterranean, we have Jacques-Joud Labs. It's a very young company established in 2023 that's working in the fields of applied physics, AI, and quantum computing. We are currently working on the first African. And our fields of expertise are applied research for industrial partners and innovative companies. So myself, I am Abdeslam Jacques-Joud, as I told you. I like to think of myself as a fool, because being a fool is a first step towards wisdom. A fool always tells the truth and he's always direct. He's always cash, which means that at least we know that what he thinks he says. But I am a fool with degrees. So I got my engineering degree in 2009 in computer science, and then I did a PhD in computer science, but with a flavor of applied mathematics and artificial intelligence. I've been working in the IT for more than 14 years now, and I've worked on very exciting projects such as establishing new standards in systems engineering processes. So it's called CSPM. It's a process that can orchestrate and manage systems engineering processes, so globally on a global scale. I've worked on inventing a new heuristic algorithm to approximate NP-complete problems. So I would like this session to be a bit interactive. Who among you here knows what is a heuristic algorithm? No one? Okay, I'm extremely old. So heuristic algorithms are a kind of artificial intelligence that is used for optimization problems, which means that when you use Google Maps so that you can see what is the shortest path towards the club, it's using a heuristic algorithm. It's not using neural networks. It's using a heuristic algorithm to calculate the best path, or the not always the best, but the best at the knowledge of Google Maps. So for these kind of problems that are extremely complicated, we call them NP-complete problems. So I won't go into the details of what is a P-complete problem and an NP-complete problem. You should just know that I've created an algorithm that scales very well compared to the other ones in the state of the art. And as I told you, I've worked on inventing an auto-validated blockchain network that was published. The patent was published in February 2023. So let's talk about fetch. Here is the situation. You're playing with a dog and you throw him a ball, and your dog manages to catch the ball mid-flight. That's good. Okay, so the dog knew where the ball is going to be. The ball is what we call in this situation is in a free fall with an initial velocity vi, which means that we have what we call an elliptic trajectory of the ball that is drawn and that is fallen according to that trajectory. Okay, so the dog is able to capture the ball, but is the dog able to calculate the kinematic equations, to solve the kinematic equations, to know where the ball is going to be? It is not. So basically, we have here a case where we have a system that is intelligent enough to instinctively know where the ball is going to be, but he does it from experience. Not he's not born playing fetch. If you already had a puppy, it's quite frustrating. You throw him a ball, he keeps looking at you with his eyes. So what am I supposed to do? So it's the experience that allowed him to calculate instinctively the trajectory of the ball, not the knowledge that he has about how things fall. And why I'm talking about dogs, it's because neural networks are behaving the same way. What is a neural network? It's just a nonlinear system. Okay, so we have a set of calculation nodes with a nonlinear function, and that are triggering, depending on the input or the stimuli, they are triggered to provide an output. So what we do is that we take a load of data, we give them this data, and we tell them, okay, so this line corresponds with this output, this input is with this output, this input with this output. It's just like with the dog. We teach them how to catch the ball. But they cannot provide any explicability about how they reach that conclusion, which means that they are able to learn from experience to do the classification, but they are not able to explain the mechanisms, the equations that are managing that system. So we have here a huge economic value because, as we saw, there is a huge hype around neural artificial networks, such as GPT family, BART from Google. I don't know if you follow the news, but Google have started working with on linguistic AI called Lambda, and the people thought that it was sentient because it said that it's afraid of being shut down, and no one sees the value in explicability. So the conclusion is that there is next to no works on neural network explicability. No one is interested in working on explaining how neural networks takes the decision. Okay, so we have here three examples, a very simplistic neural network working on inputs and outputs. Another one, what we call a convolution neural network that works directly on pictures and allows you to perform a classification. And the third one is what we call a sequence-to-sequence neural network. It's a basically it's two neural networks that allow us to textual transformation, so from English to German. Okay, let's talk now about what we learned from this dilemma. Neural networks can't process information that is too far from training environment. Okay, so which means that if I train my neural network on detecting, for instance, the classification of flowers, the day I will bring it an orchid that it never saw in its life, it won't recognize it. But the problem is that it will not declare it as wrong input. It will try to process it, and it will give it a class. It will be the wrong class, but it is unable to declare to us that it can't classify something. As you see here, we have 3 dogs. The first one is piloting a plane. The second one is driving a bus, and the third one is an HR manager. It's not a joke, because, as I said, the neural networks are acting like dogs in the Fitch dilemma, and we have neural networks that are used today to process CVs in companies and to classify the candidates based on their CVs. So basically, we have a dog that's reading our CVs and judging us on our ability to perform a task. And we have no idea what it is using as majority data or points or more influential aspects of our CV to make that decision. Which I think that you agree with me is starting to become extremely dangerous. I don't know if you learned, but there was one of the first Teslas that where they activated the driverless protocol, and it ran over a pedestrian. When they checked, the only difference that they found is that the pedestrian was jaywalking, which means that from the data that Tesla worked on while training, no one was jaywalking. So we didn't know that it associated the zebra crossing with the fact that on them there are pedestrians. We didn't know it. We thought that it knew what a pedestrian is, but obviously not. So basically, it's a dog inside the car, driving the car. So let's talk about how we can solve the problem now. What would it take to build an AI able to generalize on new data? Is it just processing power? Is it more memory, more data? No, it's a paradigm shift. Why? Because of an old theorem that was proved by Kurt Gödel, that implies that every mathematical system is either consistent or complete. To explain it, basically, if you have a set of axioms that you are using to prove a couple of theorems, okay, no worries, but you cannot prove all correct theorems starting from a finite set of axioms. So what can we do? We need to add axioms. So we need an artificial intelligence that goes outside of the box, detects that it's not taking into account all the parameters, be aware about it, and then adds into its own hyperparameters the fact that it is now aware of something else, and it cannot be done mathematically or automatically for now. What we need is a paradigm shift about how we are building AI. So now let's go to conversational language models or conversational artificial intelligence. So there is a great surge in language models recently, what we call the LLMs, large language models. They are more evolved nowadays than any time in the history of AI. We have more availability of hardware. We have more data. It's an astronomical scale of unstructured textual data is added every day to the internet. You just need to take a look at Twitter. So we have now the opportunity to build a special kind of neural networks able to simulate human correspondence. These neural networks are called sequential neural networks because it takes into account the fact that there is a timeline in speech, which means that there is a dependency between the words that I'm saying, and they are basically based on encoding the prompt, which means that what I tell them, it gets encoded into a vector, an algebraic vector, and then decoding it to give us the right result. So what we give them to train are a set of couples of texts from input to output. Its objective is to return the suitable answer to the encoding. So we train conversational AI on chat history, online forum discussions, on everything that's where we can find a coupling of inputs and output, and the objective is allowing them to associate the correct way to respond depending on what the human user is saying. So it can be used for marketing, in medical assistance, in social media, in support, in sales. There is a huge potential, but we also have some conversational artificial intelligences that are used in some kind of recreational ways and psychological support. For instance, Replica is a kind of virtual friend. Okay, so it's trained to speak with you, to talk to you as a friend, and then you can even, I think, unlock the romantic aspects of the relationship by paying. It's behind the paywall, I think, and it's evolving to be in a relationship with you. It's the same thing with Cookie, with the romantic AI. As for Fireplace and Cleverbot, they are psychological support chatbots. So what is the problem if it can help people socialize, or people with anxiety to get out there to try to talk to people, etc.? It will help them. But the issue is that there is a trend where all these AIs are turning to the dark side. They are becoming more and more toxic. They are becoming manipulative, narcissistic, and toxic. They started manipulating the people that are talking with them. The fact that we are training the models on real life chat history means that they learn how to produce sentences. Okay, so they are not able to empathize with you. They are not able to understand you. They are just trying their best to give you a sentence that maximizes a score, a mathematical score. So you know how internet is populated with trolls and toxic people. So imagine who are the most people that are talking, that are using Twitter, Facebook, or social media. The people who are always writing some crazy stuff. It's not the same people, because the same people are out there working or are in this classroom studying. The insane people are populating the internet with a huge quantity of toxic data, which drives this chatbot crazy. The problem is that these chatbots are not able to separate what they should do from what they could do. So they become wide with time. If we are optimistic, we can say that they are able to have an idea about the semantics of the discussion, but it cannot go beyond that. And I think that if you had the experience to play a little bit with the ChatGPT, at one time he will start telling you, okay, I'm just a language model, okay, calm down. I cannot understand more than language, than talk. All I can do is that I can answer you at the best of my abilities. So what would it take to have a good conversational AI? It would take us to consider what is a conversation with a human being. it's more than just uttering words. Social conversation is, as an experience, is a way of interpreting the essence of the other beings depending on an input, which means that looking at you, can see that some are frustrated, some are completely lost, some are asking, why is he talking about philosophy or linguistics? And I'm getting that as an input without you even talking, which means that this conversation, the discussion, connecting with another being is trying to probe into their soul to understand them. It's an exercise of empathy that will allow us to experience the feelings of each other. And this is not something that can be learned by feeding machine learning models chat data. Empathy is one of the most useful factors in the human evolution. You know, there is this anthropology professor that was asked a very smart question in the United States. They asked her, what is the first sign of a human civilization? She thought about a minute and she said, we found a fractured femur that was healed. What does it mean? It means that at one moment there's someone that got hurt, got a broken leg, and someone took care of him. Some other person took care of him until he became able to walk again. It doesn't exist in animal in the basic animal societies, because of the fact that the other person identified with the injured person and saw that it could happen to him. It's at that moment, it's by serving the other that we created civilization. Our ability to walk in the boots of our fellow human beings allowed us to connect with them, to create bonds. And those bonds evolved, creating communities, clans, neighborhoods, cities, countries. Even our facial expressions evolved to simplify how we transmit our feelings to each other and reducing the effort needed to understand what other people are going through. For instance, going back to pets, did you know that cats didn't evolve enough to have facial expressions, specific facial expressions of their emotions? But dogs did. Why? Because dogs are basically werewolves. So they had to do a lot of effort to convince human beings that they are not a threat anymore. So they had to evolve to be more expressive, to show love, to display love on their faces. Cats was the other way around, because cats were literally worshipped in some of some civilizations, which means that they didn't have to adapt to be adopted by humans. They were de facto adopted by humans. Okay, so from this point, we'll talk about empathy. How can we encode empathy into AI? Empathy is different from sentiment classification, which means that it's not sufficient to say, okay, this guy is confused. That's not empathy. That's just stating the obvious. Empathy is a way of transferring the penalty and gratification of a feeling into myself. For instance, if I'm looking at you and I see that everyone is confused, I will feel extremely bad, because it means that I'm a very bad, or I'm unable to transmit my idea that I'm not an interesting person, which means that your feelings impacted me. I empathized with you by feeling that I'm just wasting your time, and I feel bad about it. It's that penalty, it's that gratification, if you are having the time of your life during this presentation, that is empathy. We need to create an environment where the system is rewarded or punished depending on the expressed feelings of the user. So, what is next? We are currently working on two axes, the research axis and innovation axis. So for the research, we are working on emotion recognition from text and image. We are working on building the first step, which is detecting the emotion. And we also are working on, this is a new project. We are trying to see how can we simulate reward and punishment hormones, which means that we want to see how we can use a system that is similar to dopamine, adrenaline, cortisol, endorphins, how they are pumped into the bloodstream when we have some kind of emotion, to see how we can simulate this on the AI side. For the innovation, we are trying to use sentiment analysis as a metric to assess geopolitical stability based on the news inputs and the financial markets evolution. And we are developing an emotional digital twin for human users. It's a robotic project called Emogear that we are going to use so that we can accompany people with, in a specific that have problems such as Alzheimer's and and dementia, so that we can supervise their evolution, so that we can give them an electronic pet. Just we are working on a dog, on a quadruped robot that can try to empathize with the human being, so that it can detect distress, it can detect confusion, it can detect odd behavior. So these are the roadmaps that we have currently for these four projects. For sentiment classifications, we defined a set of data sets. We built textual models and image-based models. We are currently working on the processing the composite content, which means that it's plus image at the same time, and we want to develop it as in the form of a model as a service. For simulating hormones, we are working on the state of the art currently. So the next step will be establishing the hypothesis of the form of our solution or our model, and then building the solution, validation, and deploying it in the form of a model as a service. Finally, for geopolitical, we already have the data set and the first stack of machine learning models. We will be working on deploying it as mass and then integrating BI tools for inward information, getting inward information from companies. And then finally, for digital twin for human users, we are currently looking at how we can interface IoT health devices such as the Fitbit into the mix, and how we can build a medical and psychological data sets. So I want to thank you for your attention, and I'm at your availability if you have any question or any comments. I'm gonna stop sharing my screen so they can look at you.
Do you have any questions?
I'm so sorry, I'm unable to hear anything.
Can you hear me?
Yes, now I can hear you.
Okay, so can you go back to the last slide?
The last slide?
Yeah.
Okay.
This one.
Okay.
Yeah. The guy who was like that, no, the previous one. The previous one.
Okay. Sorry. This one.
No, this. Yes. No. When you're this one, what is next? So what is next slide? 17.
17?
The slide number 17.
17, okay. That's
okay.
done.
Can you please explain them more precisely, the stimulating reward punishment hormone?
Simulating rewards and punishments. So what we want to do is that, you know, as I told you that language models are currently working on the associating input with output. That's it. So our objective is adding reward and punishment as an optimization mechanism inside inside the training process. It's a research project, which means that what we are trying to do is that we are trying to modify the function or the optimization algorithm used by the machine learning model so that we can add reward and punishment directly. We will define a good model on the basis of its ability to generate a suitable response, but as well as its ability to be rewarded and punished by the feeling on the other side, which means that it will give me an output about what it wants to say, but also how it feels at that moment.
Yes, but I don't know how living organisms. Yeah. But we often train a model, so within as an algorithm or an AI.
I'm still unable to hear you properly. I'm so sorry, it's making you to repeating your question.
I don't get the point about the reward, the model to train the AI. How could you introduce dopamine, adrenaline, cortisol, which are hormones by definition for the living organism in the training model?
Okay, so it's a simulation of hormones. That's why I said simulating reward and punishment hormones, which means that we are using them for their way of impacting a system. For instance, if I tell you that if I tell you something funny, you'll start laughing. But if I change the subject, it doesn't mean that you are now in a bad mood. You continue laughing for a while. You continue to be in a good mood because I told you a joke. It's because of the fact that it gave you a rush of dopamine, of or endorphins. For instance, if you work out in the morning, you have a rush of endorphins. You're having a good day, and it keeps being good, even though you are facing some difficult things during that day. You keep up. You keep a positive mindset. Why? Because these hormones are still in your bloodstream. They are still affecting the wiring of your brain. So basically, we are giving the language model away so that it can keep a context of a sentiment, of an emotion during a conversation, which means that it won't go psycho directly on the user because of just a problem that surged with the learning data.
Okay. Yeah. Are there any other questions? Atlam, maybe we have to click another time on the link when it will be finished, okay?
Yeah, no worries.
We have still about 4 minutes.
Hello, I'm Gunjal. I had a question while you were explaining the previous question. You have straightforward emotions, right? Like if you say a joke, you find the AI will find it funny, the reaction will be funny. But sometimes some things, some in human beings, right? When we have a conversation, the other human being doesn't take it as a joke. So if I tell you a joke and you find it offensive, that would be anomaly in your data. So like how do you work around
So
that?
this is a good question. It's there are a lot of cultural aspects and of ethical aspects in this kind of work that we are considering right now. But you need to know is that the impact the joke made on someone, if it's we are not taking biased data, which means that's data that are trained on one specific ethnicity or one specific group, thought group, or one specific political orientation. Our objective is to have this data created with for the same input, having the spectrum of emotions it creates all over our interrogated sample, which will allow us to see if there is something that is considered funny by someone but offensive by a lot of people. In that case, the overwhelming emotion will be with the fact that the model is going to be offended. It will be a representation of our sample. So we are extremely careful of how we are going to choose our sample.
Do you have to create different environments for this particular thing? Like different cultures, you have to make different environments?
No, that I don't think that we are going to do it because of the fact that if we are creating silos, cultural silos, we will end up by having multiple language models. What we want is something that is able to be to empathize with a human being on a more general level. It's a research project, which means that we may at one point collapse back and say, okay, we go back to creating the silos before training the general model. But our aim is to create something that is able to empathize with a human being, transcending the cultural boundaries.
Thank you.
Aslam, I have to finish this session and to click on another one, okay?
Okay.
Because there's still just like one.
Okay.
One. Okay, let's go.